Hello students, in this video I will go through two examples of dividing polynomials which are very similar to the exercises that you will find that are associated with this lesson. So let's take a look. So right now I have a fourth degree polynomial that's being divided by a binomial. So this is actually very similar to rewriting the expression in this manner, where I take this dividend and it's being divided by this divisor here. So they mean the same thing, okay? So if I have this understanding, okay, and I personally prefer to write divisions, okay, as a fraction rather than to use this symbol, just because I find the use of the fraction bar, it embodies so much more, right? There's so much more, there's so many more advantages of rewriting an expression in this manner, because you can work with factors, you can work with reducing a fraction, okay? Whereas writing it out as a division problem, you are just limited to just long division, okay? So so let's take a look, okay? If the problem gets transformed into this manner here, okay? One thing I want to do is I want to check for whether or not this thing is reducible by factoring. And just looking at this, okay, and I can already tell, if you have a bit of a number sense, okay, you can tell that the left half and the right half of the numerator here, okay, will share a common factor. Can you see it? Right? If I multiply the, or if I factor out a common factor of v cubed, and if I factor out a common factor of 3, you're going to see there will be a common factor of 4v minus 3. If you don't see it, that's okay. With more experience, you will. So let's take a look, right? I can rewrite the expression to make it look like v cubed 4v minus 3 minus 3 times 4v minus 3. And the denominator I have 4v minus 3. So once I factor this out, and immediately, okay, just looking at this, I can already tell I can just reduce all three of these, and I'll be left with v cubed minus 3. But you know what? I'll just go through and continue rewriting this, okay? This is the same thing as 4v minus 3 times v cubed minus 3 all over 4v minus 3. So this gets reduced to v cubed minus 3. So if you are unable to recognize that just immediately, that is okay, because you have another trick up your sleeve, and that is you can perform long division, okay? So if you're asked to reduce this, okay, and you don't see that there's that 4v minus 3 is in fact a common factor, okay, with the numerator, then you can perform a long division. So, which I am going to demonstrate with this guy here. This is actually a this example here, okay? There's no common factor. So what am I going to do? Because there is a the numerator is not factorable, okay? I am just going to perform long division here. So 8n minus 3 divided by, 8n cubed minus 27n squared plus 65n minus 24 divided by 8n minus 3. That's how you're supposed to say it. Okay. And do I need to put in any placeholders in this? It looks like I don't need to. So what am I to do? All I got to do is I got to figure out, what do I multiply 8n minus 3 by to get 8n cubed? I got to multiply by n squared. So I will end up with 8n cubed minus 3n squared, and I'm going to perform a subtraction. And if I do, I get negative 27n squared minus negative 3n squared. So that will get me negative 24n squared. And I want to pull this down, and I get plus 65n. And then what am I going to do to multiply 8n to get negative 24n squared? I want to multiply by negative 3n. And if I do that, I'll end up with negative 24n squared plus 9n. And again, I'm going to perform that subtraction. And if I do, I get 65 minus 9, and I get 56n. And I want to pull this down, so minus 24. What am I going to multiply 8 by to get 56? I will multiply by 7. So I'm going to write plus 7. 7 times 8 is 56. 3 times 7 is 21, so it's minus 21. I am going to perform that subtraction, and I get negative 3. So what will this turn into? This will turn into n squared minus 3n plus 7 plus negative 3 over 8n minus 3. I think I'll do one more example with you guys, just because I want to demonstrate again with you all that sometimes there is a need to put in a placeholder. So I think I will do question number 14 with you guys. So this is the same thing as, again, this is the same thing as 7n cubed minus 6n squared minus 4, right? But I'm going to put in a placeholder. I want to write in plus 0n minus 4. Anytime that you're missing one of those terms, you got to put it in so that when you perform the long division, you'll have that you'll have a place to represent that placeholder. Okay, so I will multiply 7n by n squared. 7n times n squared, that gets me 7n cubed. 6 times n squared, that's minus 6n squared. Perform the subtraction. So I get negative 6n squared, so that's 0, and I want to pull this down, plus 0n. Okay? Actually, that looks like the end of the problem, because what do I have to multiply 7n by to get 0? Nothing, right? So the only thing I get is minus 4. So this whole thing reduces to n squared plus negative 4 over 7n minus 6. That was a really quick problem. I was not expecting that. Let's try maybe another one, perhaps that involves using a placeholder. Let's do number 17 here. Again, I want to do the same thing. I write 10r plus 3 on the outside, and I write in 10r to the 4th plus 3r cubed plus 0r squared plus 0r plus 10. Okay? So I want to multiply 10r by r cubed, and I will get 10r to the 4th plus 3r to the 3rd. Perform that subtraction. I end up with 0, 0, 0. This all reduces down again. This is unexpected. I did not imagine the problems would turn out to be this simple. I'll get a remainder of r because I get 0, 0, 0 everywhere. So I get a remainder of 10. So this is the same thing as r cubed plus 10 over 10r plus 3. Is there another question that I can do? Maybe that requires a little bit more involving placeholder. It looks like there is not one here. No, there isn't. All of these reduce down to very, very quickly. Okay, so I'm going to stop here then.